Okay, I think we would slowly start because it's only an hour and we try to cover a lot and introduce you to our technical but also conceptual background of the project Digital Atmosphere. So first of all, thank you for being here. It's okay if you have your camera switched off, maybe you eat in the background, that's all fine. Appreciate if you have your cameras on, but no must. And we would start sharing our screen, which gives an overview of who we are, and then the technical, all the steps we went through in the past and currently and will take in the future in order to create a digital artwork that is available throughout the UK, maybe even further one day. So let's start.
And again, just to add, we'll try and do this presentation in about 45 minutes. So it just gives us 10 minutes for any questions or further insights into like technically what we used or things like this.
But also feel free to use the chat if there are any specific questions. Okay, so there we go.
Great. So yeah, thank you for everybody who's joined today. And we're Studio Above and Below, and we're going to present a work called Digital Atmosphere, and just a bit about ourselves. So myself, Perry, and Daria, we both studied at the Royal College of Art and completed a course called Information Experience Design in 2017. Since then, we've worked on a number of projects that have primarily been funded through like art and science collaborations or arts organizations within the UK and a broader scope. And at the moment, we work as a studio practice and both practicing artists, and we work together and collectively with others. So we have one employee at the moment, and we work with a number of freelancers across the country to realize the projects that we'll present. So what we do, primarily, we create mixed reality experiences. And what we mean by this is creating augmented reality experiences, immersive experiences and interactive experiences. So we'll show you a few of these. And I guess Digital Atmosphere sits within this category, as well as computational art, so digital artworks, 3D video works, and computational design. And alongside this, we do future research, so future studies, design, innovation with other brands and collaborators, and research and development into emerging technologies. So yeah, I guess with Digital Atmosphere, part of the creation was looking at emerging technologies and exploring this in some kind of critical way.
Before we dive deep into Digital Atmosphere, we will show you a few previous projects just to give you a glance of how we work, what we work on, and so on. So this is a recent project we finished called Explorations of Digital Material Ecologies, and it was created over a period of actually only 3 weeks in Germany at the UNESCO World Heritage Zeche-Zollverein. And we explored the close by river and created a data set with this river. So we're not showing it in those slides, but we created a water buoy sculpture that we placed into the river and collected subtle movement of the water surface. And simultaneously, we took pictures of the river surface in order to create digital materials, and combining this data that we received from the water surface of the movement and the materials that we created digitally. We created this large-scale projection piece, which in real time can take this data from the river and react to it.
Yeah, just to add, we'll try and go through these quickly, and we can provide videos after if you want to see more documentation. But these works are made with primarily like games engines. So this was made with Unreal, and using Unreal gives us the chance to make real-time interactive works that use real-time data in some way. So the next project is called Aquasec, and we can share this video as well. This is a 10-minute film that also explores the River Roar, where we, over 4 months, collected a data set, a visual data set and an audio data set of water movement, stones and surrounding greenery. And through this, we fed this through something called a style GAN and used a neural network to kind of dream of these new formations of rock, greenery and surfaces. Through doing this, we created augmented reality like CGI elements that would live on the river. So we were speculating about these future networks or neural networks creating the next surfaces or elements that live within a river.
But we also, besides art commissions or R&D commissions, we also, for example, work with museums or universities. This was a project together with Humboldt University and a research group called Matter of Activity. And they created an exhibition which was about the activity of matter. And in our piece, we explored different weathering processes on geological elements, stones primarily, and processes which usually take millions of years in order to be seen. But through this VR experience, we transformed the live weather data from Berlin and took this data and influenced the stone formations and surfaces. So then I think we have to admit someone, sorry. I don't know why. Completely lost the mouse. And the person got admitted. Yeah.
So yeah, one other project that we worked on this year was called Performing Telepresence, which explored using EEG and EMG data sets. So using electrodes placed on the surface of the head by taking these subtle readings would influence like an audio and visual experience in a 360 projection room. Yeah, this work was open to exploring kind of how audio and visual experiences are made in digital spaces, like who's the protagonist in the space and how can we design new interactions in these digital spaces.
And this is the last project. After that, we dive into digital atmosphere. It's a projection installation called Atmospheric Scene, which we received a NO2 level data set of London, which was captured we received it from King's College in London, and we plotted this timestamp into this 50-kilometer square timestamp of NO2 levels in London, which are also usually not be seen with the pure eye or not even be reached in 50 kilometers above us, into a 3x3 meter projection, and people could walk through this. And here, for example, we used a software called Touch Designer for the interaction, but for example, Houdini in order to transform this data. And the reason why we showed you those 5 projects is because they all use a kind of different data set or different approach to data. And as this talk is also in collaboration with Digital Democracies by Threshold Studios, which really looks into how we can maybe also critically use or catalyze data in a more tangible way. We thought it'd be nice to show you different approaches, how we use data throughout our work. So now we would dive into digital atmosphere and the development of it. So we really try to be transparent and give you a very honest overview of how we worked on this project from beginning to end, with knowledge that we had 2 years ago, which we have now, and to really show you all the little steps that need to be taken into account when you develop an artwork using data, in our case, air pollution data for the very first time, in order to influence a mixed reality artwork. We show you this video quickly. I think it's just 30 seconds. So this is our video of digital atmosphere, and as you may know, because you may have read what this talk is about, it's a mixed reality artwork which has a physical sculpture with a sensor in the middle which reads the local air pollution and transforms this data or sends this data to a virtual system, which we built in Unity and which we, in the first stage, for example, exported onto a Magic Leap headset as a next step on a local app. And currently we're developing actually a downloadable app that could be used by people throughout the UK. And we will go into detail about all the little elements that that are in this project. But the very first idea of it was funded through an organization called Near Now in Nottingham. And we were by then interested to use, as augmented reality actually didn't boom that much as currently it does, we were interested to critically use augmented reality. So rather than just creating digital artworks or place something into the space, we were interested to use it in a meaningful way and make something visible that usually isn't visible to our eye, such as air pollution. And this is why we combined our interest of exploring augmented and mixed reality together with air pollution and live data. So the project actually has 3 stages, which we will talk you through. So stage 1 was developed end of 2019 till 2020 and funded through an R&D fellowship from Near Now on Broadway in Nottingham. And really, this is where we created the Magic Leap experience and the very first time actually working with live data and augmented reality. Stage 2 is currently still ongoing. It's actually the touring part of the project, and we have exhibited it internationally at several places, and we will also share with you, for example, later what worked well and what didn't work, all the findings about that. And stage 3 is now supported through an Arts Council grant and Threshold TV and Studio to create a standalone downloadable app. So we will work on that until next year, actually. Stage 1. So it's really a breakdown. It's we did R&D for the very first time into augmented reality using live data 2 years ago. We built an air pollution sensor from scratch, on an affordable air pollution sensor. It included the mixed reality development of using the Magic Leap headset, which we will introduce you to, but also how to combine Unity and Raspberry Pi data that we received through the sensor, and obviously also a little bit, we will show you the conceptual and scientific research into air pollution and air pollution measuring tools. So a lot of things, like it's really we will run through, but it's about learning Unity for the first time. We actually haven't been used to Unity before that project that heavily. Setting up the Magic Leap headset, building the sensor, I think implementing, we are using PM 2.5 and PM 10 data, which is which are small pollutants, which are commonly being measured in the air.
And the PM 2.5 and 10 is based on the scale of the pollutant matter. So yeah, these are very, very small pollutants that you can't see with the eye.
Building the visual effects, using the visual effects graph for 6 states of pollution in our artwork. It included sound design, the digital exports using Unity and Magic Leap, building a physical sculpture, testing the physical and digital interaction, and documentation. So really quickly, what inspired the visual, the audiovisual side of the artwork was actually explorations of early air pollution devices, which were canary birds taken by coal miners underground to sense the air actually underground. Obviously, those canary birds actually sensed not like other particles, but we were inspired by something. We were looking for a poetic element which could influence our audiovisual experience. And on the right, you see back in the days, a high-tech tool that where canary birds were placed into this object to sense those toxic gases. And we were struck by that, and this influenced our decision to switch off the sound to be inspired by actually how birds move and behave and flock together or don't flock together, and really taking this inspiration by bird movement, which is the leading point for the digital side of the artwork.
Yeah. As well as this, so some of the things that have come up when we showed this work is people asking whether these particles represent the small particles in space. But for the artwork, we weren't interested in this. We were more interested in creating some kind of digital creature or emotion towards this particle system. So less just showing pollution data as a number, but more how these digital objects can react to data.
Yeah, and behave and actually feel and sense. The physical sculpture was also then inspired by this air pollution device, which actually, is this round metal element, which in the middle there, the sensor sits in the middle, and those birds flock around. So just a little bit of the visual inspiration.
So with this project, the touring work has a physical sensor, and this sensor uses something called an Adafruit library for storing and collecting data. And we're able to do this using off-the-shelf tools such as an Arduino and a Raspberry Pi. And to do this, we worked with a studio called Studio Int. And actually with this project and the sensor itself, this is all on GitHub repository. So if you're interested after this presentation to kind of understand the ins and outs of creating one of these sensors yourselves, then this can be done with the GitHub repository. And how this sensor works, so this is a lower priced sensor for understanding small pollutants. So it uses a laser, and the bottom half of this sensor basically sucks in air through the sculpture and then passes it out through the other end. And the laser calculates how much of this small matter passes through the sensor. So this is like a common measuring technique that's used also like scientifically per like cubic meter. But actually with these sensors, more expensive scientific sensor in the city at the moment will weigh these small particles. So they'll weigh it on filters, and these filters need changing. But this is something we were aware of when working on this project, but the quality of data is still really good, and we found this by exhibiting it inside and outside on some areas like congested roads, and you can see the difference of data changing throughout the day. So yeah, with this data, we were interested in transferring these small particle matters, PM 2.5 and 10, and using these in real time to influence our augmented reality sculpture. And in order to do this, we used a technique, or we used a language JSON. And JSON is like a common way of distributing and understanding data over the web and different networks. So this is also used in games engines for like saving scores or point systems on a cloud somewhere, and same for like finance, other things like this. And we had to learn pretty much from scratch for us how to pass this data into the games engine Unity and make this data set usable within our system in some way.
But it actually updates every 2 seconds, sends it to a local server on the web, and Unity receives it, and or the exported app receives it and updates the flocking system.
And sorry, just to add with this as well. So in terms of like these data sets being transferred over the web, so like mobile devices, we're also storing that data. So when we exhibit the work in a public space, or in the past in like museum spaces, we're actually keeping those data sets for the X amount of days that we exhibit there. So not that we're like analyzing this in too much detail, but like this kind of comes with a body of work as well, like collecting that data as well as presenting like real-time data through an augmented reality experience. Yeah, so just to, here's a few screenshots of a games engine called Unity. So if you're not familiar with Unity, this is actually a free piece of software that you can download to use to create games applications. So primarily Unity, like 60% of like mobile games on the market are actually made with Unity, the games engine. And we worked with this to create the augmented reality experience. And we used something called the Unity visual effects graph, which allowed us to create real-time interactive particle systems. And the visual effects graph uses a node language, so built on the language of C#. In Unity, you can program kind of these systems using nodes as the logic. So it is very much like a visual programming language. And throughout like a lot of work that we do, including other softwares such as Touch Designer or using Unreal Engine, primarily working with like visual node programming.
And yeah, so we had this data, and we're thinking, how do we express this through the flocking system, which we create through this visual effects graph that Harry just described. And we actually categorize it into 6 different stages of air pollution, which can be measured, which is good, satisfactory, moderately polluted, poor, very poor, and severe. And this influences the different stages that people can experience in the artwork. So on the left side, for example, they said it's the flocking system is actually always held in a like a infinitive sign, how we call it, because it sits well around the physical sculpture we created. But it flies from time to time. However, this data influences actually their constant behavior. So for example, on the left, you see it's state 1 where there's less pollution taking place, and state 6 is more polluted. And we have those different states. So actually the data influences those little parameters in the VFX graph. And the more polluted it gets, the more chaotic audio and visual becomes. So, whoop.
So just to give you an idea of what's going on here. So yeah, the real-time data from our sensor can influence the Boyd system and how these agents are moving. So in that video, we tried to give you just a quick overview of how these changing states are happening and how visually the outcomes look.
Sorry, I have to go into this view, otherwise I can't play the sounds. But at the same time, we developed the sound design of the piece together with a sound artist called Rainer Verholz. And for example, throughout the work, we talked to scientists and, for example, asked, okay, how does air pollution actually sound like? And something that sounds very mundane, but which I didn't think about during that point, is actually the louder it is, for example, in the city, if you hear like a lot of construction or cars, the more polluted it actually is. So, which was very, obviously air pollution can also be very calm, but in the city you can be sure if it's really loud around you, there's actually more pollution. And this was, for example, one influence that came into the sound design, as well as the bird and some bird sounds that you hear in the beginning of the sound design and which you cannot hear, for example, in the last stage. So yeah, so we wanted it to, that the last stage, for example, is almost like a warning tool, that it's not that it becomes very okay.
So yeah, with those stages, both the visual and audio, if it is too polluted, we want people not to spend as much time with the work in some way. So yeah, the cleaner the air, the more pleasant the art experience is in some way. So to develop this work at first, we were interested in presenting it on the Magic Leap headset, and this headset is a mixed reality headset, and what that means is it presents both the real world through the glasses but also digital overlays. And we worked to develop the system that we just showed to work on the Magic Leap itself. But first of all, we used something called an emulator, and this was before we had the mixed reality headset. And these emulators are available for also other mixed reality headsets, such as like the HoloLens 1 and 2, where you can test how the kind of spatial mapping and the physics and the interaction with objects will work on the headset without having to purchase or use the headset itself. So this was quite a good way to kind of start prototyping on the project without investing into buying the product until we had something ready to go. So yeah, these are some videos. These are some videos of the first test that we were able to do with the Magic Leap headset now. So this is either me or Daria wearing the headset at home, and you can see in the left image we're doing some tracking and plane detection in the space. So the wire mesh that is appearing is where the LiDAR scanners on the headset are detecting whether there's a physical wall or an object in that space. We were doing this at first because we were interested in exploring whether these particle systems also interacted with the physical world. But when we tied this back to the physical sculpture, they just interact with the physical sculpture itself. But you can see on the right, this is a digital version of the physical sculpture where we were able to prototype how this system looked and how the physical sculpture looked without having to actually build it yet.
Mm-hmm. And actually this was like the end of stage 1, where we had the physical sculpture in place after that, and the virtual flocking system, and you can experience that through the Magic Leap headset. And that's why at the end we actually created this documentation video, which really also talks about our thoughts behind it, and how in the future, for example, this could be explored in the city and throughout in different streets, which we are now exploring actually through the app that we are developing with Threshold Studio. So yeah, end of stage 1. Let's get to stage 2, which is the international touring bit, which means, okay, adjusting actually the physical and digital sculpture for short and long-term exhibits, and indoors and outdoors, troubleshooting for the first time remotely, and corrections, building several sensors if it's been exhibited simultaneously somewhere, managing the entire touring, and receiving feedback, because we actually created this artwork throughout lockdown, and actually all those touring elements were the first time that we received feedback, which is really, really helpful for us. So it was and can be exhibited with the Magic Leap headset. However, because of several reasons, we also created an iPad and iPhone setup. For example, because we didn't know if actually exhibition places really want to have headsets because of COVID, and also because of other technical challenges that we faced.
And just to add, what gave us the advantage here working in the games engine Unity is it does work cross-platform. So we could quite easily transfer our project that was built for the Magic Leap into an iOS experience.
So just a few setup images and how, for example, where we exhibited it and what we learned is on the left side, you see was the first time exhibited in the beginning of the year at Tech Basel for 3 months with the headset. And we were very excited because it could finally be shown. But for example, we tested it for several days in our studio. However, what, for example, didn't work, which we learned after that, is every time people actually put the headset away onto the plinth that you see on the left side, it actually loses track and you have to recalibrate or rearrange the flocking system in itself. So we knew we have to work on the anchoring of our virtual system in the next stages.
And then, yeah, as well as this, on the right is a picture of one of the sensors that we're currently exhibiting in Düsseldorf at NRV Forum, a museum. And the sensor itself is outside for 6 months. So to this day, it's been there about 2 months and nothing's broken yet, which is great. So we're hoping, yeah, it will last outside 6 months. But yeah, this has been like for us learning how to weatherproof and ensure that the hardware is suitable to be outside for these long periods of time.
Mm-hmm. And how, for example, the setup on the right works is actually there is a sensor for 6 months outdoors. And as Perry said, we will have the data after 6 months, which will also be exciting for us just to see how it changes over several periods, or night and day, and weekends and so on. However, this is actually the museum itself built a standalone app with several AR artworks, and ours is the only one which uses data, but actually this data is being sent to the museum's app, which people can download. On the left, for example, this is a smaller setup at Freedom Festival, which where we only exhibited the sensor, because the physical sculpture had to be somewhere else at that time, and people can experience it with the iPad indoors. And on the right, this was at the V&A for 2 weeks during the London Design Festival and Digital Design Weekend. And this actually worked really well because we were there for the first time and could actually see how people interact with it. We will show you the videos. Sound, so I can talk over it, but it worked with the iPad, and over 3,000 people crossed the space over the period, and it was, we would call it, quite bulletproof, so people could really take it, scan the sculpture, it stayed in place, received the data, and actually, because it is on an iPad, every time someone was using it, a bubble of people was behind the person and experienced it with the person. So it really actually attracted quite a lot of interaction and positive feedback. And we were, we were very surprised how positive people actually reacted to it and how well this technical setup worked. So
yeah, you can see the augmented reality work here, but also on the iPad in the bottom right corner, you can see the real-time readings of the PM10 and 2.5 levels.
Yeah. So actually our takeaways from all the exhibits we had so far are, every time we exhibited, we learned a lot, and actually getting feedback from people is super helpful. I think the one takeaway we mentioned in the beginning, that we realized the anchoring of the virtual sculpture is quite a challenge, but through a physical marker-based scanning, which in our case, the sculpture is the physical marker, it worked actually best way so far. Stage 3, which we are currently in, and the dates are actually wrong here, sorry. It started 2 months ago and goes until the end of next year with the support of Arts Council and Threshold Studios. And as I said, we are currently developing a public downloadable app, so people can really experience it in their city, across the country, and it would also allow people to experience the other cities, for example, remotely. So we're developing the content for the app, which we also learned from feedback of the exhibitions that actually, all the conceptual elements that we had in the beginning with the early air pollution devices and bird flocking systems. This is something we want to bring back here and really immerse people actually in this entire storytelling. But obviously it includes all the visual programming of the app, and educational part of the experience, which we want to include, and new data sourcing, because how the sculpture currently works is it has it has the one sensor which reads the local air, but we will need to use an API of data sets, air pollution data sets across the UK. So this is a different data managing now. And we hope to do that at least over 12 months, because receiving this data actually costs, and we will test it for 12 months. And what it also includes is talking more to air pollution scientists to really receive actually feedback on the data, but also just critical feedback for all those elements. So this is a map, you don't have to follow it completely, but it's also actually the first time for us developing a standalone app, and it's about thinking about all those elements. And we will quickly introduce you to what this will include. So we'll actually include in the beginning an experiential part, and then it goes into a UK map. The actual digital experience, so people can, there's a typo, sorry, digital experience, so they can experience the virtual sculpture in their place and maybe take a picture and also share it. Then there's an educational element, which will actually introduce what are those pollutants in the air and how do they look or feel like in comparison to other elements that surround us. Because if you hear PM 2.5 and PM 10, it's quite abstract and not everyone knows what that actually means. Generally learning about air pollution, the air quality index that we showed, those different stages that also our sculpture goes through, how to fight air pollution in the everyday, just advice and tips for that, and a little bit about climate activism. So we are currently in the prototyping stage, and really the app may not look like this in a few months, but it's just allows us to prototype. And this is an introduction bit, which will have the flocking system, maybe some provocative questions. Then people can actually experience the map of the UK in augmented reality and choose between the city that they want to experience. This then goes into the actual experience, which, for example, this is York. It could also be another city that you experience, and the current PM levels. And then, the educational bit, as said, these are the 5 elements we would like to bring in. But we are interested, for example, to make the pollutant part, where we actually want people to introduce how does PM10 and PM 2.5 look like in relation, for example, to other particles that surround us. So we imagine this is going to be an augmented reality part as well, where people can experience those pollutants.
So I guess the second part of this project is how we source the data. So at the moment we're looking at different back-end data sources and speaking to different atmospheric scientists about how reliable this data is in real time. So the project itself isn't about visualizing historical data, but using real-time data to influence the artworks and experience in this data. So we've looked at a number of data sources that we can use, and this is something that's still ongoing, that we haven't decided on yet, but we hope over the next month or two to decide on those data sets. So in terms of using a data set, at the moment we're storing each of the 69, 70 cities in the UK. And with this in an Excel sheet, we have a unique reference key and link to a data feed for each one of those cities. So at the moment, this takes an average level of pollutants in the city. This might not be in the center of the city. It could be the closest sensor to that city. This is the thing about like reliability in real-time pollutant like sensors and data across the UK. Like there isn't a true location in most cities what that pollution level is in real time. We've discovered, maybe by being like too speculative and like challenging the idea of where pollution lays on the street, but something we want to take further in the future. And in terms of data sources, we're learning how to store these ourselves now on a server space using this JSON, again, a readable text. And we retrieve a lot of data from these libraries, but what we're really interested in is the name of these locations and PM 2.5 and 10, and storing this data for the next 12 months. So obviously our work tries to be critical with whatever emerging technologies we're using, as we tried to show with mixed reality and augmented reality. And for the first time for us, this is trying to upscale a project by using remote cloud services and storage of data and larger data sets, even though it's only a tiny, minute part of cloud services. Like with this project, we're trying to be critical about like using carbon neutral spaces right now, the same as like using Unity, which aims to like offset its carbon emissions already. So we feel like this, if we're trying to upscale this work and think about like carbon neutral services, like designing even on a small scale right now should try to be carbon neutral as possible. So we're looking into different cloud services that offer this, as well as like the techniques we use to build this service.
We're almost at the end of our talk, just so you know. But at the same time, as I said, we're also talking to Imperial College and Brighton University, which both look into air pollution data to have those conversations and not just assume that we as artists and designers working with technology know everything. So throughout the next steps, we hope after building all the app, all the parts of it, we definitely want to do some user testing, critically reflect on the data that Perry just mentioned, and also research more into how we could really create a call for action through this experience. So thank you to all the supporters so far. They are growing, and we are very happy for all the institutions and people that supported us, but also allowed us to exhibit our piece there and receive the feedback. And maybe last thing, if you want to get in touch, or if you may be working in a similar field or intrigued, or even want to talk about this, or a air pollution scientist and stuff, please get in touch. We would be happy about that. So thank you for staying here.
So we have about 5 minutes left, and we're open for any questions, or if you want us to discuss any part of the presentation in a bit more detail, we're happy to do that as well.
But it's also okay to stay silent. We're happy that people joined over lunch. As said, you could ask questions now. You could also drop us an email. The piece is going to be exhibited or can be experienced in Lincoln in 2 weeks at the Frequency Festival. Tomorrow in 2 weeks, Friday and Saturday in Lincoln at Exchange Square. For more information, we posted the frequency link in the chat. But yeah, thank you so much.
Yeah, I think we can also put our website into the chat, where the other projects that we quickly presented at the start of the presentation, where you can find out a bit more detail, and there's also videos and more images and documentation of those works if you're interested. But yeah, if you do have any other questions after this, like feel free to email us as well. So yeah, we're interested in like learning about these technologies, but also sharing knowledge. So myself and Daria also have run several workshops and are interested in sharing our knowledge. So yeah, feel free to email us if you have any like technical questions as well.
Otherwise, let's say if people don't have questions, you're allowed to leave and have 5 more minutes of your lunch break, or
okay. Thank you so much for this. This was great. If you do have any more questions, you can also write to the email from which you got the link to this session, and I'll pass them on to Daria and Perry. So yeah, if you come up with any questions, please feel free to do that. The recording of this session will soon be available on our Digital Democracies website as well. So if you need to go through a reminder, you will be able to do that.
Perfect. Great. Thank you so much.
Thank you.
Thank you.